Hello students, welcome to this video. In this video, we will solve 10 more problems of mathematical induction. Like previous video, these are divisibility problems. So 61 to 70 we will solve. The link to download the PDF will be in description. As well as at the end, I will show you how you can download the updated copy of PDF and my question answer website, which I have developed for you for asking questions. So without further ado, let's get started. Question 61 says that show that if n is in the set of natural numbers, 3 raised to the power 2n minus 1 is divisible by 8. So we put n is equal to 1, we get 3 square minus 1, that is 8, which is divisible by 8. So the statement is true for n is equal to 1. We let it be true for n is equal to m. So we have got pm is equal to 3 raised to the power 2m minus 1 is equal to 8k. We let that. Next, we substitute n is equal to n plus 1. We get 3 raised to the power 2m plus 2 minus 1, which is equal to 8 times 3 raised to the power 2m plus 8k, which is divisible by 8. And hence, by induction, we have the result. Question 62 says that show that if n is in the set of natural numbers 10 raised to the power n plus 3 times 4 raised to the power n plus 2 plus 5 is divisible by n, 9. So we let n to do the given expression and we substitute n is equal to 1. We get 10 plus 3 times 4 to the power 3 plus 5, which is 297, which is divisible by 9. So the statement is true for n is equal to 1. We let it be true for n is equal to m. We get P of m is equal to 10 raised to the power m plus 3 times 4 raised to the power m plus 2 plus 5 is equal to 9k, where k is in the set of natural numbers. Now we put n is equal to m plus 1. We get 10 raised to the power m plus 1 plus 3 times 4 raised to the power m plus 3 plus 5, which is equal to 9 times 10 to the power m plus 9 times 4 raised to the power m plus 3 plus 9k, which is divisible by 9, and hence by induction we have the result. Question 63 says that show that we will go fast, so I will not read everything entirely. 5 raised to the power 2n plus 1 plus 2 raised to the power n plus 4 plus 2 raised to the power n plus 1 is divisible by 23. We put n is equal to 1, we get 161, which is divisible by 23. Now we put n is equal to m, we get pm. We let it be equal to 23k, where k is the usual. We substitute n is equal to m plus 1, we get this, which we expand, we get this, which is equal to 23 plus 5 raised to the power 2n plus 1 plus 2 into 23k, which is divisible by 23, and hence we have the result. Question 64, the expression is 7 raised to the power 2n minus 1, and it has to be divisible by 8. So I put n is equal to 1, we get 48. So it is true for n is equal to 1. We substitute n is equal to m. We have this expression, which we let equal to 8k. Now we substitute n is equal to 1 plus 1, and we take out 2 power. We get 49 times 7 raised to the power 2m minus 1, which is equal to 48 times 7 raised to the power 2m plus 48k. Okay, so there is something wrong here. This should be 8k, not 48k. Okay. Yeah, this should be 8k, not 48. And hence by induction we have the result. Question 65 says that 3 raised to the power 2n plus 2 minus 8n minus 9 divisible by 8. We substitute n is equal to 1, we get 64, which is divisible by 8. We let it be true for n is equal to n, so we have this condition where k is in the set of natural numbers. Now we substitute n is equal to n plus 1, we get 3 raised to the power 2n plus 2 minus 8n plus 1 minus 9, which is equal to 8 times 3 raised to the power 2n plus 2 plus 8k minus 8. Yep. So that is divisible by 8 as well, and hence by induction we have the result. Question 66, the expression is 41 to the power n minus 14 raised to the power n should be divisible by 27. We put n is equal to 1, we get 27, so it is divisible by 27. Now we put n is equal to m, we let it be equal to 27k, we have got 41 raised to the power m minus 14 raised to the power m. And then we have got 41 raised to the power m plus 1 minus 14 raised to the power m plus 1 is equal to 27 times 41 raised to the power m plus 27k, which is divisible by 27, and hence by induction we have the result. Question 67, the expression is 15 raised to the power 2n minus 1 plus 1 should be divisible by 16. We put n is equal to 1, we get 16, and then we put n is equal to m, we let the expression be equal to 16k, then we put n is equal to m plus 1, we get 15 raised to the power 2m plus 1 plus 1, which is equal to 225 times 15 raised to the power 2m minus 1 plus 1, which is equal to 224 plus, times 15 raised to the power 2m minus 1 plus 16k. There should be a k, it is missing, and it is divisible by 16, hence by induction we have resolved. Question 68, the expression is 5 raised to the power 2n plus 1 plus 3 raised to the power n plus 2 times 2 raised to the power n minus 1 should be divisible by 19. We put n is equal to 1, we get 152, which is divisible by 19. We put n is equal to m, we have this expression equal to 19k. That is what we assume. And then we substitute n is equal to m plus 1, we get to this expression, and we take out 5 square, 3 and 2 outside, we get 25 times 5 raised to the power n plus 1 plus 6 times 3 raised to the power m plus 2 times 2 raised to the power m minus 1 is equal to 19 times 5 raised to the power m minus 1 plus 6 n times 19k, which is divisible by 19, and hence by induction we have the result. Question 69 says that the expression is 10 raised to the power n plus 3 times 4 raised to the power n plus 2 plus 5 should be divisible by 9. We put n is equal to 1, we get 207, which is divisible by 9. Yep. And then we put n is equal to m, so we let the expression be equal to 9k. And then we put n is equal to m plus 1, we take 10 out from this and 4 out from this. We get 10 times 10 raised to the power m plus 12 times 4 raised to the power m plus 3 plus 5, which is equal to 3 times 2 times 10 to the power m minus 5 plus 4 times 9k. Now we will prove that 2 times 10 to the power m minus 5 is divisible by 3. We put n is equal to 1, we get q1 is equal to 15, so it is divisible by 3. Now we substitute n is equal to m. Qm is equal to 2 times 10 to the power m minus 5 is equal to 3s, whereas in the set of natural numbers, we substitute n is equal to m plus 1, 2 times 10 to the power m plus 1 minus 5 is equal to 20 times 10 to the power m, which is equal to 18 times 10 to the power m plus 3s, which is divisible by 3, and hence by induction we have the result. Now we come to the last question. The expression is 9 raised to the power n minus 8n minus 1, which is divisible by 64. We put n is equal to 1, we get 9 minus 8 minus 1, which is 0, divisible by 64. Now we let n is equal to m, we get 9 raised to the power m minus 8m minus 1 is equal to 64k. We substitute n is equal to m plus 1, we finally arrive at 9 times 9 raised to the power m minus 8m minus 1. So if you see carefully, this is already divisible by 64, and hence the entire result is divisible by 64, and hence by induction we have the result. And with this we come to the end of 7th set of problems on induction. Now this is the website. You can download algebra, trigonometry and coordinate geometry books, and when you download you add the date, because the links won't contain the date, and after 15 or 30 days, something like that, you should come again and see what update has been made to the books, and then you should download the PDF again. I cannot add the date because it will make all existing links invalid. And if you have to ask questions, you can click on the 8th link, come to tondika.astrotalk.org. Here you can ask mathematics questions. You have tags here for algebra, calculus, coordinate geometry, geometry, probability, and trigonometry. YouTube is not really suitable for mathematical content, so here you can ask. And if you look at markdown help, then you will see that it does support math using MathJax tool. So you can use math here and you can ask your questions and I'll be happy to answer your question. So thanks a lot for watching the video. I hope that you have enjoyed this video and found it useful. And if you have not watched the videos on the playlist, then make sure that you watch those and get benefit from the videos. So once again, thanks a lot for watching the video. I will see you tomorrow with 10 more problems on mathematical induction. I will take my leave here and you have a great day and enjoy.